Thank you so much. Yeah, I'm going to talk today about making your fabric work. And this session might feel a little bit like I'm going to knock on fabric or tell it it's not really that strong. That's not the point of this session. I've been trying to do a lot of horrible things to fabric to show you what happens and what you can do about it and where to look. So the thing is, if my clicker would work, thank you very much. The thing is, we need some definitions because my session is about load testing fabric and I'm going to use a large amount of data. But what is a large amount of data? I mean, suppose you're a small corner shop in the outskirts of a medium city. Say the city has 50,000 inhabitants. If you get 100 customers a day, it can be a large amount of people. And they pay you money and you need to register it, and that's data. And for you, that can be a lot of data. And if you need to enter it all into your accounting system and do all the ordering and all the stuff, it will be tedious and it might ruin a perfect summer evening, or like it right now in the Netherlands, it's raining and horrible, so it's not that bad. So suppose you're running a store in the city center. You might be getting 1,000 customers a day, getting some items from your store, paying stuff, and you need to register it and order new stuff and keep on going. At that point, 1,000 customers is a lot of data, and having the 100 ones you had on the outskirts isn't all that much. Well, suppose business is going well, you've got multiple locations, things are growing, you get 10,000, 20,000 people in your shops. All of a sudden, you've got a new definition of a lot of data or a lot of people or whatever. So depending on how you look at stuff, a lot of data, a large amount of people, it differs. So there's no fixed definition of what is a lot of data. It's all in the eye of the beholder. So I'm going to set the definition for this session. And that's for my load testing. I will be processing about 6 billion rows of data. That table is called order lines. And I'm going to connect it to a table called orders. It's got about 1 billion lines. I'm sorry, 1 billion rows. And I've got some dimensional information which has about a few million rows. All in all, it adds up to about 500 to 600 gigabytes of data. That's my definition for this session of a large amount of data. Your company, your work, your reality will probably define a large amount of data differently. So let's start about load testing. So how I'm going to load test stuff? I mean, I could put a pigeon on a mooring cable. Yeah, it will hold, no problem, because mooring cable is designed to keep a ship at the docks, and usually those are a little bit heavier than your regular pigeon. The other thing is, what will this processing of all those rows tell us? I mean, it's a fun exercise, it will tell me some stuff, but your reality again will be different. And how will these results transfer to your own world? It's a question I can't answer because I can't jump into your head, and that's maybe for the best as well. But let me take you back to May 2023. Fabric dropped at Microsoft Build last year, and I was outside watching my son training on his racing bike, standing in the sun, and all of a sudden my phone went wild. Everybody was pushing messages, posting on LinkedIn, X, Twitter, Mastodon, Blue Sky, what have you. There's a new tool in town and you need to know about this, and it's the most amazing thing that will be there. Cool, so I was scrolling on my phone and thought, all right, I need to dig into this. So as soon as we got back home, put my son in the shower, gave him some food, I ran to my laptop, and it was a long evening. Because I wanted to know what was happening. I wanted to see what it could do. Now I'm the global administrator of the company's tenant I work for, so for me it was quite easy to make myself a Fabric admin, log into fabric.microsoft.com, app.fabric@microsoft.com and start a trial and see what's what. And I started doing the end-to-end tutorials from Microsoft Learn. And these work. I mean, it's AdventureWorks. It's a small data set. It really, a few gigabytes of data, 10, 20, 30,000 rows, something like that. Of course it works, especially against an F64 engine like Anupama talked about in the session before this one. It works because F64 is quite powerful. If you've got small data sets, sure, no problem. But what if you get more realistic? We process more data. Will the F64 still be able to process it, or can you get by with a smaller F SKU? So I decided to try stuff out. Now I'm coming from a SQL world, as you can see. I'm working for Axians as a data engineer, data solutions architect. I'm doing all kinds of stuff, blogging a lot at my website. You can find me online when you're looking for to meet a DBA. I was bestowed the honor of Microsoft Most Valuable Professional this January, which made it quite easy for me because I didn't have to renew this time. I will have to do that next time. And since 2020, I'm a Microsoft certified trainer as well. The QR code on the left will take you to my GitHub, where you can find all the slides and all the scripts I've been using. And I've been doing unspeakable things to F2 SKU since 2023 for science. This stamp, if you will, was initiated or inspired by a remark from Alexander Arvidsson, also known as ArcticDBA. So yes, I've been breaking the F2, and we'll get to that later in the session. But before going into all kind of stuff, let's start with my background. I'm coming from the SQL world. And when you're in the SQL world, things are relatively simple. You start your query, and when you want to measure performance, you can check out your processor load, your memory usage, and your disk I/O. And of course, time you need to finish the query, but right, that's runtime. It's simplifying, but by and large, these are the most important parts, and there are a lot of fun and cool details that I won't get into today. But with Fabric, things are very different. My data processing is done on clusters somewhere in the magic background. The only control I've got over them is by scaling my capacity units up and down, and I'll get into the capacity units in a second. Quite simply put, if I'm giving my Fabric environment more capacity units, I'm giving it more power. And if it were that simple, measurements would be relatively easy, because more power means my notebook, my pipeline, my data flow, whatever I'm running will finish faster, and I'll be done quicker, and all right, that's it. But things get more complicated because Fabric has introduced the concept of bursting and smoothing. And that's where things get fun. Because it means your process can go way faster than your capacity might allow, but it's borrowing performance from the future. And if you're borrowing stuff, you need to give it back or pay it back. And it might cost you dearly later on. So let's zoom in on this one a little bit. And one of my coworkers came up with a great analogy. In the Netherlands, we've got a number of roads where there are speed cameras that will not give you a fine immediately, but take a picture of your number plate with a timestamp. And say 20 kilometers down the road, there's a second one. It takes another picture of your number plate with a timestamp. And between those two cameras, you need to have driven, or your speed must not have exceeded a certain number. So for instance, you can't drive faster on that piece of road than 100 kilometers an hour on average. So if you're starting out running into it with 130 kilometers an hour, that's fine. I mean, the camera won't fine you for speeding. But if you keep going 130, at the end, you've been speeding with 30 kilometers an hour and you will pay the fine. If you slow down halfway and make sure your average is 100, you're fine. And the same happens with Fabric. You can overuse your capacity for some time, but then you need to pay back what you've overused. And if you're doing that a little bit, it will be fine. If you're doing that a little bit too much, your user might get headaches because they will be waiting. And if you're doing it too much, like I did, your capacity will stop working, fail, throw angry errors, stuff like that. So to get to grips with that, you need to be able to use the capacity app that Microsoft provides. But before I get onto that, let's get into that. Because I've set up my definitions for load testing. So for this session, I know my definition of a large amount of data is a large data set created by TPCH or by TPCH software, and I'm going to process billions of rows. Now I need to convert my SQL experience and turn it into what's happening into Fabric. But we need to dig in a little bit deeper. So we need to learn the Fabric capacity app, and we need to learn about what the capacity is and what capacity units are, because then those are weird. So let's talk about the capacity units. It feels a bit like magic, and the first time I heard about them, this was about what I thought of them. It's magic, some stuff is happening, and at some point it will make sense. So let's make it easy. 1 second of work equals 1 capacity unit. This I could understand. If I'm deploying an F2 capacity, which is the lowest capacity you can get, and it costs you about 300 euros a month, you're going to get 2 capacity units per second. Now, capacity units are evaluated in blocks of 30 seconds. This is where it gets interesting, because an F2 will give you the number of 60 capacity units. So I've got 1 capacity unit for each second of work. My F2 has 2 capacity units for each second. I'm evaluating in blocks of 30 seconds. So I've got 60 capacity units that will show up in my capacity units or in my capacity app dashboard. If I've got an F64, it's 64 times 30 seconds is 1920. So this will somehow start making sense when you start working with it. In the end, when your capacity runs out, it's running out of processing power in the end. You need to add more capacity units, or if it works for your mind, add more processors. So when you look into the Fabric Capacity Metrics app, you get the multi-metric ribbon chart, which is fun. It will give you this image where you can see I've been running a pipelines, a notebook, warehouse, maybe even an event stream or other stuff. Depending on what you're doing, you can see all kinds of colors appear in this chart and see stuff happen, which is cool. But this in itself doesn't say anything because there are no numbers on the left side. So I don't know if the bar on the left is really high or really low or whatever. So when you hover over these things, you get this. On Tuesday the 2nd, I had a Synapse notebook that was using 495,720 capacity units. Cool. The difficult thing is, this is compiled over the entire day. So it's summing all through the day. So you need to divide it and find out if it fits in your capacity, which is, well, extra work, and I don't want to do that. So let's move a little over to the right, where we can find the capacity utilization and throttling graph. This is where we can find the interesting stuff, but now, because now when you hover over these bars, and I'll show you that one later on in this presentation, you can see how much it was using in that 30-second time span. I don't know how you call it. Within those 30 seconds, how much capacity units it was using. And it gives you an idea how much you've been using in your capacity. What you can also see, let's see if I can get my mouse at the right point, is this. It starts building up and it slowly starts to go down again. This is your smoothing. a little bit of your smoothing effect. It's been spreading out the load. Something else you can see is that there are gaps between the bars. The thing with this app is it's not always recording everything that's happening or showing it. I don't know what's happening in the background, but at times it's missing a little bit of data. So you need to kind of assume that those gaps are not gaps, but the capacity was running all the time. And when we're talking about utilization and throttling, these are the numbers Microsoft gave us with overage protection. You can use 10 minutes of your future capacity without throttling, which means you can use extra capacity and you won't really feel it. And the more you start using it, the more stuff will happen, to the point that if you're running into background rejection, if your scheduled background jobs will get rejected, and people will get angry. I've been doing a lot of testing on our company capacity, and at some point co-workers came up to me and asked me to stop doing that because they wanted to do some stuff as well and were tired of seeing your capacity is overused, please wait. So I can hover over one of these bars, and I can even drill through to all kinds of sub-information and other stuff. Let's not go into that one right now, maybe later, but for now, there's a lot of extra information in time point details where you can learn and see what's happening. All right. So far, large amounts of data, it's just a matter of perspective. How you look at it, what you want to do. Fabric allows you to learn new skills, let's put it that way. And measuring your Fabric capacity usage is one of them. It is a skill. It's not easy. It's not, oh, I've got this dashboard and I know what's happening. It will take time to understand what's happening there. It will take time to find out what it means for your daily workload. Take your time with this one. All right. So let's go from all this theory to creating data. So I'm using the TPCH data set, which means I need to create a lot of data. This is the command you can use. The thing is, you need to be able to create this dbgen.exe file. And to create this one, you need to download the binaries and compile it yourself. I've given you a few examples of what you can do with it. And if it runs, and it's fine. What you can also do is create some kind of update and delete set, so you can mimic stuff happening in your company, which can be really fun to see what happens if you start delta loading, incremental loads, stuff like that. You can create those data sets as well. The database schema is relatively simple. It's a normalized schema where you've got parts, part suppliers, line items, stuff like that. The fun thing is, in this diagram, the more rows a table has, the more columns it has as well. So my nation table has 25 rows and has 4 columns. My region table has 3 columns and 5 rows. It expands. The more columns you can see, the more rows it can generate, which kind of makes sense, but it can also help in overloading your system, which is what I'm after. It creates an enormous amount of file, which is cool. They're all officially CSV files, and it runs. This screenshot is a bit hard to read, but this is just a list of files that was created, ranging from 394 bytes for my region table, 5 rows, 3 columns, to 76 gigabytes for one line item table, which contains about 1 billion rows. So the TPCA stuff is free. The data inside is complete nonsense, so you can easily share it. It is a bit quicker to get it running, but it is very flexible because you can create small data sets from 1 gigabyte to millions of gigabytes, terabytes, whatever you want. Now, before we start the actual load testing, there's one thing you need to be aware of. If you want to load data into Fabric, there are 3 ways to get it in there, maybe more, but let's generalize a bit on these 3. If you're using a pipeline, like the ones we're used to in ADF, you can either load to a Fabric Lakehouse or Fabric Warehouse. If you're using a Fabric Dataflow Gen 2, you can load to your warehouse or your lakehouse. If you're using a notebook, you can only load to your Fabric Lakehouse. You can't write out to a warehouse. Well, maybe with a little bit of tricky, but in general, just a lakehouse. So that begs the question, what is the best fit? Because some people like life easy, and the pipeline is quite easy. Source, target, get the data in, done. But the pipeline has, well, let's not call it a lack of, but not as many data connectors as the Dataflow Gen 2 has. So it depends on what you want to achieve. A Fabric notebook has ways to connect to source systems, but in my personal opinion, it's a better fit to move data from one lakehouse to another through your medallion architecture or however you want to design your data warehouse. So you need to think about, all right, what do I want to do? How do I want to ingest my data, process my data, model my data? So let's start loading. I've been doing a lot of stuff trying to find out what's happening. I've been using the pipelines and notebooks and the Dataflow Gen 2. Now, as I said, you can use a pipeline to get data from your source, write it in a lakehouse or warehouse. It's just a difference of how you move your data. In a pipeline, you can change the data type, and that's about it, really. If you want to really modify stuff, you need to add queries, stuff like that. But if you're just loading, say, XML files, querying those XMLs won't really help. So the notebook and the Dataflow Gen 2 have way more options to model and join and do a lot of cool stuff. So that question still remains, what's the best tool for which scenario? What's the best fit? So let's see what the pipeline can do. The pipeline is relatively easygoing. I've created a pipeline where I'm reading my source data from my storage account, my CSV files, and then it's going to write it to a lakehouse. You can choose a warehouse or a KQL database as well. KQL doesn't make any sense in this scenario because it's not time series data, it's just static data in the end. So lakehouse or warehouse is the best fit. I've done nothing with settings, so it's all set to auto. My fault tolerance, skip missing files. If something happens, just skip it, move along and see what happens. So let's see. The pipeline F64 ran for 33 minutes. It had a balanced optimized throughput, cool, 638 parallel copies, and was done. 335 megabytes per second process. Reading badly formed CSV files, writing out Parquet. The Delta Parquet that's being used in Fabric. All right, so the F2, will it be slow or quicker? I was wondering, I thought, well, let's give it a go and see what happens. It doesn't really matter. This time the duration was 32 minutes, 39 seconds. So it was mildly quicker than the F64, but still, yeah, difference? No, not really. So in this case, it doesn't really matter if I'm using an F2 or an F64. I'm still processing the same amount of rows, same stuff. In this case, I don't really care. So how much capacity units was it using? Because that's where I start caring. What you can see is that in this scenario, and this is a screenshot from the F2, it has been using 43 capacity units from the 60 I've got available. And I see I messed up this screenshot just a tiny bit because At the bottom here, it should say 100% in CUs in total should be 60. But I've been using 43, which comes to a percentage of 73%. All right, cool. I can live with that. You can also see is that it's been running for quite some time here in the background. There's a long block of usage. So it's not, even though it's 33 minutes, there's 10 p.m. here, 11 here. This is a smoothing effect. It's been smoothing out my load. So secretly, it's been using more capacity. It's not showing me. Something to always keep in the back of your mind. If you see this graph, what's happening? Let's go to the F64. It's 10 times higher. Correct, because I ran this one 10 times to find out if it's really stable or not. So here you can see the 100% ECUs is 1920. I've been using 400, running it 2 times, and it's still only using 22%. In this specific case, the F64 was just lounging back and thinking, yeah, anything else you want me to do? So you could generalize and say the F2 is used at capacity almost, and the F64 is way over provisioned. If you were to dig down into this report, you could find these time point CUs where you can see what's happening, and there's some weird explanation. Again, coming back to the fact that I'm using capacity every 30 seconds. All right, so the F2 is running at 73%, the F64 at 2.2%. So what else is going on? I mean, you're not just ingesting data into Fabric and then be done with it. You want to do more. So let's start the code. Let's start using notebooks. So if I want to ingest data, in this case, I've already copied my CSV files into a lakehouse, because connecting to my storage account meant I had to hardcode all kinds of stuff, do horrible things, and then I didn't want to do that. So I made my life a little bit easier, stored my CSV files in my lakehouse, and I can reference them. What I'm doing here is, this is my source, all my CSV files, customer table 1, 2, 3, 4, and 5. I'm creating a table which I'm naming raw_customers, because at this time schemas were not available. They are in, so I kind of sort of preview right now, I think. We've got a schema where I've got a customer key, name, address, nation key, for all these things, all my columns, and an empty one. Because my files are slightly malformed, stupid stuff is happening. And it's creating an empty column. If I'm not adding this empty column, the process will fail. I'm going to read my CSV file from my folder path. There's no header. Malformed records may be dropped, because in this case I don't care. I've got a pipe, a separator, and my schema is this one. Then I'm going to write into a Delta format to my tables. And when I ran this one on my F2 capacity, it finished in 2 minutes and 29 seconds. Cool. And it processed 120 million rows, which is even more cool because I've never been able to do that with any other ETL tooling I've been working with. To me, this is fast. So I was wondering, what can the F64 do? How much faster can it be? Because it's 32 times more expensive. So will it be 32 times faster? Nope, it's about 2 times faster. 1 minute and 30 seconds it took to process all these rows, which may or may not have something to do with the speed that the underlying OneLake can give me the data. So let's do the large one, the line items. Same process, same script. And the F2 took 2 hours and 4 minutes to process 4.2 billion rows. So there was a lot of losing data because there were way more rows available. And the F64, 7 minutes. This is where you can see where the F64 starts to excel, because this is where it's starting to really power through, go parallel, process all your stuff. It is way faster. This was the moment I thought, okay, the F64 has some merits. It can do stuff. So let's see how much CUs it used. 56. It's using 56 capacity units of my available 60. So now my F2 is almost at capacity. And that's where stuff starts to get dangerous. Because if you're going to run multiple notebooks at the same time, you're done. Because this one will almost completely use the capacity. The second one will just go over the 100% line and you'll be dead in the water. So when I'm going to the F64, you can see there's a different way of smoothing it out. And all of a sudden I'm using more CUs. I'm using more cores, if you will, and the process is going faster. Which is fun because I want to process my data as fast as I can. Cool. And right now it's running at 15%. Still, it's not really working all that hard. But at least it's doing something. On my F2 you can see that my interactive delay was almost hit. I'm slowly beginning to get throttled. So the speed of my F2 is slowly limited. And it'll get more and more and more and more. This was the F64, which has, in the end it's still lounging. So let's add a column to my table. Let's call it fact orders, which it isn't, because all I'm doing is I'm adding 3 columns, year, quarter and month, based on the order date inside the column, and see what happens. On the F2, it ran for 18 minutes and 7 seconds, as you can see here. So I'm thinking, well, the F64 should be way faster, maybe a minute or something like that, processing 770 million rows. 8 minutes and 20 seconds. So I'm going from 18 minutes to 8. About twice the speed. Not exactly what I was hoping for, to be honest. But then again, it's reading, stuff can be happening. So let's join my 2 biggest tables. I'm creating a fact order lines. Again, it's not a fact, but let's pretend it is. And join, what you can see here, my order lines on my order keys. And see what happens. Let's see how much time it takes. On the F2, it took 2 hours and 16 seconds. The F64 took 14. What you need to be aware of, that sometimes you can see this Apache Spark session ready in 2 minutes and 39 seconds. Don't think this is the time it took to process this notebook cell. It's just starting the Spark session. Command executed in 14 minutes and 51 seconds. That's what you want to. That's what you need to be looking for. So this took. I went from hours to minutes. Cool. Again, you can see the F64 really doing its work. The funny thing is, I really couldn't see my join in my capacity units because it maxed out on 15. Again, it was smoothing it out. It's just that the F2 doesn't have more Spark cores to do all the work. It just needs more time. It's not that it's using fully loading all the stuff. It's just running out of breath. So this for the notebooks. Let's go to the pipelines. And this one, this part of the presentation was changed in the last few days because there was something new happening. So if I'm using a regular pipeline and I thought, well, let's join orders and line items. Just bring paint to it immediately. See what happens. In PowerBI, you can see I've got my source, my navigation because I clicked the stuff. I've got a merge query and again a navigation to expand the join table. Nothing weird happening. Nothing. No stupid things. And boom. This was the first one I got. The SQL pool is warming up. Please try again. At first I thought this was a fluke, an error I get once and that'll be it. I've seen this one coming back in the last few months over and over again. At times, for some reason, you get this message. It'll be gone within 1 or 2 minutes, but I don't know where it's coming from. But it's something you need to be aware of. You need to have some kind of retry logic to fix this. After this one was fixed, I reran the pipeline and I got this. It failed after almost 2 hours of using a lot of capacity units. So let's dig into the details, because when you look inside Fabric, you can find details. This is not helpful. An external error occurred while refreshing the data flow. Unable to refresh the data flow because your organization's Fabric compute capacity has exceeded its limits. I knew that. The thing is, you can't change anything at that point because your capacity unit is kind of down. It's done. You can't change, you can't click, you can't do anything. So what was happening? Well, I got into these figures, and it should have shown this one first, I think. My total CUs is over the 100% part. So right now I'm borrowing from the future, and I kept borrowing from the future for a long time. And I wanted to go this way. It kept adding for days, for hours and hours and hours and days. So you can see this one, my cumulative write access, my overusage went to 22,000%. My expected minutes burned down 110. This kept adding and adding and adding and adding. When you see this one, you're in trouble because it will take a long time for you to burn down. I think I'll show you some more details at the end of the session. But now there's a turbo button. This is where things got fun. Because there's an option called fast copy. So when you're going, you're building your data flow Gen 2 pipeline, you go into the options and to scale. There's a checkbox that says allow use of fast copy connectors. Click that one, and it will allow the use of that one. Now there was a little bug in there that it didn't always use it, so you had to check the require fast copy as well on your query for your source. I heard something about a fix, need to try it out. And it works really fast because I tried it out. Without my fast copy, even my ingestion failed. It just doesn't work, both on F2 and F64. With the fast copy, the F64 succeeds. Without the fast copy, I saw that it needed at the maximum 394 CUs. On the fast copy, it only needed 78. So the F2 will still fail, but the F4, which has 120 CUs, might succeed. Still, the joining of the table still fails, but then again, it's a lot of work, and maybe it's just too much data for the data flow Gen 2. So use the notebooks for that one. Now, people who know me know that I'm bad at designing stuff. So me and Power BI is not a happy marriage. Let's put it that way. So let's see what happens if I do something into Power BI. I've created a semantic model with tables that I've joined. This part I can understand. And I just thought, let's create a report to see what happens if I drag stuff into this. So I got this one. The result set of query to external data source has exceeded the maximum allowed size of 1 million rows. Because there are limitations in Power BI depending on the way you ingest or read data, how many rows you can show. And maybe doing a visual on 1 million rows isn't the best idea either. So I click close, and then I got this one. Unable to load model due to reaching capacity limits. Oops. All right. So see details. Yep. That's what I thought. I can't do this. All right. So what did I do? Well, this. This is the overages graph, which you can find in the capacity app, where you can see how much it's adding to your overage, how much it's collected from the future, and now you're going to start to have to pay back. But this one can keep going for some time because I was naughty. And you can see I went over 20,000%. And this one built up at about 3 times my capacity usage. This one burns down at my capacity usage, which means this one was building up at from my F2 at 180 capacity units per 30 seconds. This one was burning down at 60 capacity units per 30 seconds, which meant this was 3 times this, which took quite a long time, as you can see in this graph. From it just took way too long. So can I speed it up? Well, yes, you can. One way to do this is to increase your capacity. This was my burn down speed at F2. When I upgraded my F2 to an F8, this happened. So my burn down rate went from 42% to 85%. It goes faster and faster and faster. The other option you've got is to pause your capacity. What happens is that Microsoft just adds the capacity you still need to burn down to your Azure bill. So instead of paying 300 euros a month, you'll probably be paying 350, 400, depending on how much capacity needed to burn. You need to burn down before you could use your capacity again. It gets added to your bill. So those are your options to speed down your burn down. The best option is to test all your stuff out, find out which capacity you need, and scale in between to make sure your capacity matches your usage. All right, let's summarize quickly, because I'm almost at time. So pipeline ingestion didn't really matter. Ingesting my 120 million rows, well, it went about twice as fast. My line items, 17 times as fast, 4.2 billion. Changing a little bit of data in a table of 773 million rows, about twice as fast for the F64. And just combining all the stuff went from 2 hours to 40 minutes, so about 9 times as fast. If this would have been my entire ETL process from ingestion to modeling, my F2 would have been working about 5 hours, whilst the F64 would have been working about 65 minutes. All right, so I've got a bit of a feeling of what needs to be done. So now there's a balance between, all right, how much money am I willing to pay, and how quick does my ETL need to finish? I've included a slide where you can see what's the background of my fabric. So if I've got an F2, I've got 2 capacity units, which means I can use 4 Spark cores in the end. That's the point where your performance lives. If I'm using an F64, I've got 128 Spark cores. It will be faster. So this will give you an idea, maybe if you're coming from Synapse and you know how many Spark cores you're using there, you've got a bit of an idea about which SKU you should start out with. So the results? Test your workload. Compare the number, review duration, review your CUs. If you want to know more about the TPCH dataset, I've included a few links to help you get going and use the stuff. If you want to know more about the Fabric Capacity app, there are a few links here to find out what's happening. And thank you so much for attending my session. My name is Reitse Eskens.